Okay, so in this one here, we've described a few key features here. And so we're just going to mock them into our axes and just see what a possible graph might look like. The first things we're told are it has a vertical asymptote at x equal to -1. Okay, so you can see that written down through here, and a horizontal asymptote at y equal to 2. All right, so from this point here, we could be thinking of a hyperbola or a truncus. F of 0 is equal to 0, so we go through the origin, which is what we've got. Okay, f of -4 is also equal to 0. So there's my two intercepts. So now we've got to make decisions. Well, we get a feel for probably where we're going to be below that horizontal axis. Now it says there that the gradient of the line is less than 0 if x is less than -1. So we've got a negative slope um, to the left of that vertical asymptote. So there's my negative slope. And then to the right of that asymptote, we've got a positive slope because the gradient is positive. So that's a typical possible graph. I guess the non-negotiables in reality are my intercepts, the asymptotes. Really, I guess the steepness of your curve is the one that could be a little bit here or there. Right. If we consider B, the cubic function has stationary points such that h dash of P is equal to 0 and h dash of Q is equal to 0. So at P and Q, at the point P and the point Q, we have stationary points. Right. The graph of H passes through the points P2 and Q5. So there's the coordinates of those stationary points. Okay, the equation h of x plus c equals. All right, so if I plot those points, it soon become really obvious that it had to be a negative cubic function to get through both of those points. Okay, so there's my graph, and now we want to know where we need to, what does C need to be to make sure we have three solutions. So to have three solutions, it means my graph has got to cut 3 times. Yeah, which means I'm going to need to have the stationary points either side of the axis, which is what I've got here. To have three solutions if the turning points are either side of the x-axis, which means I've got to shift the graph down at least -2 units, or slightly more than -2 units to bring this asymptote, this turning point, the left turning point below the axis, but I can't take it down more than 5 because I want the right asymptote to stay above us, right turning point to stay above, which means I've got to take it down between -5 and -2. So I've certainly just had to think about that. C is greater than -5, so if I take it down anything up to 5 units, that turning point on the right will be above the line. As long as I take it down more than 2 units, the left one will be below the line. So that should fix it up. So it gives me C.